In 2017, Oumuamua became the first confirmed interstellar visitor to our solar system, sparking debates about its true nature. Now, with the recent discovery of 3I/Atlas in 2025, scientists are comparing these mysterious objects and finding that Oumuamua's bizarre properties look increasingly artificial. While most interstellar objects behave predictably, Oumuamua's strange acceleration, unusual shape and reflective surface continue to defy explanation. The more we learn about typical interstellar objects, the more Oumuamua stands out as something potentially extraordinary and possibly not natural at all. The discovery of 3I/Atlas. The discovery of 3I/Atlas in January 2025 by the Asteroid Terrestrial Impact Last Alert System marked humanity's third confirmed interstellar visitor. Unlike its predecessors, 3I/Atlas immediately displayed characteristics that astronomers expected from natural interstellar objects. Dr. Robert Warwick, who also discovered Oumuamua, led the initial observations that confirmed the object's hyperbolic trajectory and interstellar origin. 3I/Atlas measures approximately 200 meters in diameter and exhibits a normal comet-like behavior, with visible outgassing as it approaches the Sun. The object's spectroscopic signature matches typical solar system comets, containing water ice, carbon monoxide, and dust particles. Most importantly, 3I/Atlas follows predictable orbital mechanics without any unexplained acceleration. Its discovery comes at a crucial time when scientists are still debating the nature of Oumuamua, providing a control group for comparison. The stark differences between these interstellar visitors have only deepened the mystery surrounding Oumuamua's true identity and origin, making the earlier object appear increasingly anomalous in comparison. The Oumuamua discovery. On October 19, 2017, the Pan-STARRS-1 telescope in Hawaii detected a fast-moving object that would revolutionize our understanding of interstellar visitors. Initially designated A2017U1, the object's trajectory calculations revealed it was traveling too fast to be gravitationally bound to our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast confirmed the object's interstellar origin within days of discovery. Scientists quickly realized they were observing humanity's first confirmed visitor from another star system, prompting an immediate naming ceremony. The object received the Hawaiian name Oumuamua, meaning messenger from afar arriving first, reflecting its historic significance. However, classification proved challenging. Oumuamua showed no visible coma or tail typically associated with comets, leading to its initial designation as an asteroid. Yet, its trajectory and composition didn't match typical asteroids either. Dr. Marco Michelli from the European Space Agency noted that Oumuamua represented an entirely new category of celestial object, requiring unprecedented international cooperation to study before it disappeared forever into deep space. Oumuamua's strange properties. Oumuamua's physical characteristics immediately set it apart from any known solar system object. Light curve analysis conducted by Dr. Karen Meach from the University of Hawaii revealed dramatic brightness variations of a 10-to-1 ratio, suggesting an extremely elongated shape unlike any asteroid or comet previously observed. The object appeared to be 400 meters long and only 40 meters wide, giving it a cigar-like appearance that tumbled end over end every 7.3 hours. Dr. Wes Fraser from Queen's University Belfast noted that such extreme elongation would be impossible for a natural object to maintain over interstellar distances without being torn apart by gravitational forces. Oumuamua's surface composition also proved puzzling. Spectroscopic observations showed a reddish coloration consistent with organic compounds, yet the object reflected sunlight far more efficiently than expected. The combination of unusual shape, high reflectivity, and lack of detectable water ice or other volatile compounds created a profile that matched no known category of cosmic debris, leading to intense speculation about its true nature and possible artificial origin. The acceleration mystery. The most perplexing aspect of Oumuamua really emerged when Dr. Marco Michelli analyzed precise tracking data from, multiple observatories. Rather than following a predictable gravitational trajectory, Oumuamua actually exhibited unexplained acceleration away from the Sun beginning in June 2017. This non-gravitational acceleration measured approximately 2.5 times 10 to the -4th meters per second squared. It's small but statistically significant and, consistent across multiple observations. Typically, such acceleration results from outgassing as comets approach the sun, creating a sort of rocket effect that pushes the object forward. However, Spitzer Space Telescope observations led by Dr. Davide Farnochia from NASA JPL found no evidence of dust particles, water vapor, or any other materials being ejected from Oumuamua's surface. The object appeared completely inert, showing no coma, tail, or detectable outgassing that could explain its acceleration. This combination of measurable thrust without a visible propulsion mechanism created an unprecedented puzzle in solar system dynamics, forcing scientists to consider explanations that challenge conventional understanding of how celestial objects behave in space, including, even the possibility of artificial technology. Scientific investigations. So, following Oumuamua's departure, scientists launched these intensive investigations to understand its, anomalous properties. Dr. Alan Jackson from Arizona State University led studies using Hubble Space Telescope data to refine measurements of the object's acceleration and rotation. The Spitzer Space Telescope observations, coordinated by Dr. Davide Farnochia, proved crucial in ruling out traditional comet-like outgassing as the source of Oumuamua's acceleration. These infrared observations detected no thermal emission from dust particles that would accompany normal cometary activity. Radio telescope arrays led by Breakthrough Listen conducted extensive searches for artificial signals but, honestly, found no evidence of technological emissions. Dr. Abraham Loeb from Harvard University argued that the lack of detectable outgassing, combined with the object's high reflectivity, suggested Oumuamua might have an artificial origin. The reflective surface discovery became particularly significant when scientists calculated that Oumuamua reflected 10 times more light than typical asteroids, indicating either an unusual composition or possibly an artificially manufactured surface designed for maximum light reflection, kinda like a solar sail technology. The alien hypothesis. Dr. Abraham Loeb, chair of Harvard's astronomy department, proposed the most controversial explanation for Oumuamua's behavior. It could be an artificial light sail created by an extraterrestrial civilization. In his 2021 book Extraterrestrial, Loeb argued that Oumuamua's combination of extreme elongation, high reflectivity, and unexplained acceleration matched theoretical designs for interstellar probes powered by starlight. The light sail hypothesis explained how Oumuamua could accelerate without detectable outgassing. Radiation pressure from sunlight could push against a thin, highly reflective surface, creating the observed non-gravitational forces. Dr. Loeb calculated that a sail just millimeters thick, but hundreds of meters wide, could generate the measured acceleration while remaining stable during its tumbling motion. He noted that such technology is already being developed by human civilization, making it, plausible that advanced aliens might deploy similar reconnaissance probes throughout the galaxy. The hypothesis gained attention because it provided a unified explanation for all of Oumuamua's anomalous properties, though it required accepting the extraordinary possibility that we had detected our first piece of alien technology visiting our solar system. The Dark Comet Theory. So, the Dark Comet Theory was put forward by Dr. Daryl Seligman from the University of Chicago and Dr. Gregory Laughlin from Yale University as a natural alternative to explain Oumuamua's mysterious acceleration. Their dark comet theory suggests that the object could actually be made up mostly of solid hydrogen, which would sublimate or turn directly from solid to gas when heated by the sun. Now, unlike water ice or other volatile substances, hydrogen gas is, basically invisible to most telescopes, and that could explain why no outgassing was detected, even though the object was speeding up. Dr. Seligman worked out that hydrogen ice could stay stable during its long interstellar journey through the cold vacuum of space, so the object's structure could be preserved over millions of years. Then, as Oumuamua got closer to the sun, the surface would heat up, causing hydrogen to sublimate and create these invisible jets of gas. Jets that could actually cause the weird acceleration scientists observed. The theory also helped explain the object's unusual density and structural stability. Hydrogen ice is light enough to let Oumuamua keep its elongated shape without collapsing under its own gravity. The ongoing debate. So the debate is still going strong. Even though the dark comet theory has a lot of scientific appeal, Dr. Abraham Loeb remains pretty skeptical of purely natural explanations for Oumuamua's behavior. In interviews from 2023, Loeb argued that the hydrogen ice hypothesis faces some significant problems, like, for example, the extreme rarity of hydrogen-rich objects in our solar system, and the really precise timing needed for such an object to visit Earth. He also pointed out that hydrogen ice would just keep sublimating during interstellar travel, which makes it pretty unlikely that enough material could actually survive the million-year journey from the nearest star systems. On the other hand, Dr. Seligman countered these objections with updated models, showing that subsurface hydrogen could stay protected beneath a thin crust of heavier materials. But, the scientific community is still deeply divided on Oumuamua's true nature. Dr. Jane Green from NASA Ames noted that both explanations require accepting either extremely rare natural phenomena or, honestly, unprecedented artificial technology. This whole debate really highlights some fundamental questions about scientific methodology, like do extraordinary claims require extraordinary evidence, and how should scientists approach phenomena that just don't fit into existing paradigms? It's definitely challenging our understanding of what's possible in the universe. Project Lyra mission concept. So, recognizing that ground-based observations just can't resolve the mystery of Oumuamua, Dr. Andreas Hein from the University of Luxembourg proposed something pretty ambitious: Project Lyra. It's a mission designed to intercept and study the object before it disappears forever. The mission concept, which was developed with collaboration from ESA and NASA, would launch a high-speed probe that's actually capable of catching up to Oumuamua, even with its velocity of 26 kilometers per second relative to Earth. Dr. Adam Hibbard from the Initiative for Interstellar Studies calculated that such a mission would need some really advanced propulsion technology, including ion drives and gravity assists from multiple planets, to reach the necessary speed. The probe would be equipped with high-resolution cameras, spectrometers, and particle detectors, so it could definitively determine Oumuamua's composition and structure. There are launch windows for Project Lyra until 2029, and after that, the object will just be too distant for any foreseeable technology to reach. Dr. Hein emphasized that this is basically humanity's only opportunity to directly examine our first confirmed interstellar visitor, and maybe answer one of the most important questions in astronomy. Are we looking at natural phenomena, or could this actually be alien technology? The Future Hunt. Looking to the future, the Vera C. Rubin Observatory, which will begin operations in 2025, represents our best hope for discovering and studying future interstellar visitors. Dr. Lynn Jones from the University of Washington is leading efforts to optimize the observatory's legacy survey of space and time, specifically for detecting objects like Oumuamua, and with enough advance warning to allow for detailed study. Thanks to the observatory's unprecedented sensitivity and wide field of view, it should be able to detect dozens of interstellar objects every year, giving us a statistical sample to figure out whether Oumuamua is a rare anomaly or part of a larger population of unusual visitors. Dr. Robert Warwick predicts that within 5 years we'll have enough interstellar object discoveries to definitively classify Oumuamua as either natural or artificial. If most interstellar visitors behave like normal comets and asteroids, then Oumuamua's uniqueness will only strengthen arguments for its artificial nature. But if a lot of interstellar objects show unusual properties, it could point to previously unknown natural formation processes. Either way, the ongoing mystery has already transformed asteroid and comet research, pushing scientists to expand their understanding of what's possible in the universe and to get ready for unexpected discoveries. The discovery of 3I/Atlas has actually given us some crucial context, making Oumuamua seem even more anomalous. While 3I/Atlas behaves exactly the way scientists expect natural interstellar objects to behave, Oumuamua's combination of unexplained acceleration, extreme elongation and high reflectivity just keeps defying conventional explanations. Whether it turns out to be advanced alien technology or an entirely new class of natural phenomena, Oumuamua has, without a doubt, permanently changed our perspective on what could be traveling between the stars. So, which explanation do you find most convincing? Share your thoughts below. And hey, if you enjoyed this cosmic mystery, hit like, share with your fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. Voyager 1, humanity's pioneering explorer, has defied all expectations since its 1977 launch. Now, more than 4 decades into its journey beyond the heliosphere, it continues revealing hidden cosmic phenomena. Recent encounters in deep space have confirmed fears long held by scientists about the unknown dangers and mysteries lurking in interstellar space, fundamentally redefining our understanding of the universe and our place within it. The birth of a star sailor. Voyager 1 emerged from an era of unprecedented ambition and innovation, conceived during the 1970s as part of NASA's ambitious Voyager program designed to explore the outer solar system. Built by the Jet Propulsion Laboratory with project scientist Ed Stone overseeing the mission direction, Voyager 1 was equipped with an advanced suite of scientific instruments specifically designed to survive the harsh environment of deep space. Launched on September 5, 1977, it embarked on what would become humanity's most audacious journey into the cosmic unknown, destined to become the first human-made object to reach true interstellar space. The spacecraft carries humanity's hopes and dreams across the galaxy, immortalized in the included golden record containing sounds and images representing Earth's incredible diversity. This remarkable machine, weighing just 722 kilograms, would eventually travel farther from home than any other human creation, becoming our species' first ambassador to the stars and opening entirely new frontiers in space exploration that continue inspiring generations of scientists and dreamers worldwide. The Grand Tour. The Voyager mission represented an unprecedented grand tour of the outer planets, taking advantage of a rare planetary alignment that occurs only once every 175 years. Voyager 1's carefully planned trajectory included spectacular flybys of Jupiter in 1979 and Saturn in 1980, delivering breathtaking images and groundbreaking scientific data that completely transformed our understanding of planetary science. The spacecraft's discoveries included detailed observations of Jupiter's Great Red Spot, revealing its complex atmospheric dynamics, and unprecedented views of Saturn's intricate ring system that showed structures far more complex than anyone had imagined. Each planetary encounter expanded our knowledge of the solar system's architecture while using gravitational assist to propel the spacecraft toward its ultimate destination in interstellar space. Project scientist Edward Stone marveled at how the mission consistently surpassed all initial goals and expectations, providing discoveries that revolutionized multiple fields of astronomy. The Grand Tour established Voyager as one of the most successful space missions in human history, setting the stage for even more remarkable discoveries that would come decades later as it ventured into the unknown realm beyond our solar system. The Golden Record. Voyager 1 famously carries the Golden Record, an extraordinary phonograph disc containing sounds and images carefully selected to represent Earth's incredible diversity and humanity's greatest achievements. Conceived and overseen by a team led by renowned astronomer Carl Sagan, this remarkable time capsule includes greetings in 55 languages, music from various cultures spanning classical compositions to folk songs, and natural sounds from Earth's environment including whale songs, thunderstorms, and human heartbeats. The record serves as both humanity's ultimate time capsule and our most ambitious attempt at communication with potential extraterrestrial intelligence that might someday encounter the spacecraft drifting through interstellar space. The Golden Record's ingenious design included detailed instructions for decoding its contents, with diagrams showing how to construct a record player and locate Earth within the galaxy using pulsar map coordinates. Decades later, this golden disc has become an enduring symbol of human unity, curiosity, and our deep desire for connection across the vast cosmos, immortalizing our quest to reach beyond our planetary boundaries and establish meaningful contact with whatever intelligent life might exist among the stars. Years in the void. For more than 4 decades, Voyager 1 has journeyed through the vast darkness of space, continuously transmitting invaluable scientific data as it passed beyond the asteroid belt and entered the outer reaches of our solar system. Despite traveling more than 150 astronomical units from the Sun, a distance so immense that radio signals now take over 22 hours to reach Earth, its sophisticated instruments continue functioning remarkably well, providing unique insights into space weather patterns, cosmic ray behavior, and the complex dynamics of solar-wind interactions. Mission operations at NASA's Jet Propulsion Laboratory have faced unprecedented challenges including steadily weakening power levels, extreme communication delays, and the need to manage aging systems designed in the 1970s using modern computer technology. Engineers have performed miraculous feats of remote troubleshooting, developing innovative techniques to maintain spacecraft health across interstellar distances while conserving precious power resources. Voyager 1's extraordinary longevity represents a testament to both robust engineering design and humanity's persistent determination to explore frontiers far beyond our known boundaries, proving that human ingenuity can overcome seemingly impossible technical challenges. Crossing the boundary. In August 2012, Voyager 1 achieved a historic milestone by crossing the heliopause, the mysterious boundary where the sun's influence dramatically diminishes and true interstellar space begins. This unprecedented achievement represented humanity's first tentative step into the vast galactic environment beyond our solar system's protective bubble. Scientific instruments on board detected dramatic changes in plasma density, magnetic field strength, and cosmic ray intensity, providing definitive evidence that the spacecraft had entered an entirely new cosmic environment never before directly explored by human technology. The spacecraft's signals confirmed that solar wind particles had given way to the interstellar medium, a historic validation of decades-old theoretical models about the heliosphere's structure and behavior. Mission scientist Ed Stone heralded this discovery as a triumph of human exploration, marking humanity's transition from inhabitants of a single solar system to active explorers of the broader galactic neighborhood. Subsequent measurements have continued refining our understanding of this complex boundary region, revealing unexpected turbulence and magnetic field configurations that challenge existing models. This crossing established Voyager 1 as humanity's first true interstellar spacecraft, opening entirely new chapters in space exploration and cosmic discovery. Signals from nowhere. Voyager's sophisticated instruments have detected enigmatic radio signals emanating from regions far beyond our solar system, creating one of the most perplexing mysteries in modern astrophysics. These mysterious signals from nowhere exhibit unusual patterns and characteristics that remain inconsistent with any known natural sources or previously understood cosmic phenomena. Leading the investigation into these anomalous transmissions, astrophysicist Donald Gurnett and his research team continue analyzing whether these signals originate from interstellar plasma oscillations, unknown cosmic ray interactions, or potentially even more exotic phenomena that challenge current understanding of physics. Some researchers hypothesize that these signals might result from interactions with mysterious magnetic structures, unknown particle fields, or previously undiscovered processes operating within the interstellar medium itself. The phenomenon has forced scientists to reconsider existing astrophysical models and may point toward entirely new physics operating in the vast spaces between stars. These continuing discoveries affirm that our galaxy remains profoundly mysterious, harboring phenomena that extend far beyond current scientific comprehension, and suggesting that interstellar space contains secrets that could revolutionize our understanding of cosmic processes and the fundamental nature of reality itself. The temperature mystery. Temperature measurements from Voyager 1 continue defying initial scientific expectations and creating new puzzles about the nature of interstellar space. Despite existing in the supposedly frigid environment beyond the heliosphere, instruments aboard the spacecraft have recorded unexpected temperature fluctuations and anomalously warm zones that challenge conventional models of interstellar medium behavior. Leading researcher Bill Kurth and his colleagues have analyzed extensive data suggesting complex thermal processes and unprecedented turbulence occurring in this mysterious boundary region between solar and galactic environments. These surprising findings significantly complicate existing models of interstellar medium properties, implying far more dynamic and complex interactions between particles, magnetic fields, and energy sources than previously theorized by astrophysicists. The temperature anomalies suggest active heating mechanisms that could involve magnetic field reconnection events, shockwave propagation, or entirely unknown physical processes operating on galactic scales. Understanding these thermal mysteries offers crucial insights about our sun's broader galactic environment and potential hazards that future spacecraft might encounter when venturing beyond our solar system. The discoveries underscore how much remains unknown about the cosmic environment surrounding our solar system and the fundamental processes shaping interstellar space. Changing course. Voyager 1's trajectory has exhibited subtle but measurable course changes over time, creating new mysteries about forces operating in interstellar space. These deviations appear to result from complex gravitational influences and unexpected interactions with interstellar matter that weren't fully anticipated by mission planners. Analysts at NASA's Jet Propulsion Laboratory, including project scientist Suzanne Dodd, have carefully documented trajectory deviations that cannot be completely explained by existing models of solar gravitational effects alone. The observed course changes may arise from interstellar wind pressures, gravitational effects from unseen cosmic structures, or potentially even interactions with dark matter concentrations or gas clouds drifting through our local galactic neighborhood. Continuous tracking and sophisticated data analysis provide valuable insights that inform navigation strategies and propulsion requirements for future deep space missions venturing beyond the heliosphere. These findings highlight the remarkably dynamic nature of the galactic environment and demonstrate the critical need for adaptive mission designs capable of responding to unexpected conditions. The trajectory modifications reveal that interstellar space contains forces and influences that extend far beyond current scientific understanding, suggesting that future interstellar missions will face challenges that remain largely unknown and unpredictable. Ghost in the machine. The spacecraft's onboard systems occasionally exhibit unexplained glitches and anomalous behavior that has led some mission specialists to speculate about a metaphorical ghost in the machine affecting Voyager's operations. NASA engineers continuously address these technological anomalies through increasingly sophisticated remote troubleshooting techniques, working across impossible distances to maintain spacecraft functionality. Some hypothesized issues relate to cosmic radiation impacts, gradually affecting electronic components, while others may result from normal aging processes in hardware systems originally designed for much shorter operational lifespans. The mysterious nature of these intermittent glitches adds a distinctly human element to the otherwise mechanical journey of Voyager 1 through the cosmic void. Mission engineer Linda Spilker frequently remarks on the extraordinary challenges of operating technology that's now over 4 decades old, while maintaining functionality across interstellar distances that test the absolute limits of human engineering capabilities. These technical anomalies serve as constant reminders of the spacecraft's remarkable resilience and the incredible ingenuity of the engineering teams who continue supporting its mission. The glitches also highlight how little we understand about the long-term effects of interstellar environment exposure on sophisticated electronic systems, creating valuable lessons for future interstellar mission design. Patterns within patterns. Voyager 1's continuous stream of scientific data has revealed intricate nested patterns in cosmic rays, magnetic fields, and plasma waves that researchers have dubbed patterns within patterns, complex structures that hint at deeper organizational principles operating throughout interstellar space. Leading physicist Donald Gurnett uses these unprecedented observations to develop sophisticated computer models of the interstellar medium's complex structure, revealing organizational patterns that extend across vast scales throughout our local galactic neighborhood. These nested fluctuations and systematic variations hint at turbulent cascade processes and magnetic reconnection events that may be actively shaping the galaxy's environmental conditions over cosmic timescales. The continuous analysis and interpretation of such cosmic complexity underscores the virtually endless frontier that astrophysical research represents and humanity's enduring quest to understand our place within the broader universe. Each new data transmission from Voyager reveals additional layers of cosmic organization that challenge existing theoretical frameworks and demand new approaches to understanding galactic physics. The discoveries demonstrate that even the seemingly empty spaces between stars contain rich, dynamic structures that influence cosmic evolution processes. These patterns suggest that interstellar space operates according to fundamental physical principles that remain largely mysterious, despite decades of intensive scientific investigation and theoretical development. Voyager 1's impossible encounter with the mysteries of deep space has both confirmed our worst fears and revealed profound cosmic secrets that challenge everything we thought we knew. As humanity's first interstellar ambassador, it continues providing unprecedented insights into phenomena beyond our solar system. The spacecraft's remarkable journey highlights both human ingenuity and the vast mysteries awaiting discovery in the cosmos. Which of these revelations surprised you most? Share your thoughts below. If you found this cosmic journey fascinating, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more extraordinary discoveries from the final frontier. 15 billion miles from Earth, NASA's ancient Voyager 1 spacecraft just detected something that shouldn't exist. 305 massive objects moving in perfect formation through the darkness of interstellar space. These aren't planets, asteroids, or comets. They're something else entirely, gliding through the void with deliberate precision that defies every law of physics we understand. The objects appeared to communicate with each other through rhythmic pulses, maintained impossible trajectories, and displayed behaviors that left NASA scientists questioning everything they thought they knew about the universe beyond our solar system. The Lonely Pioneer's shocking discovery. What if humanity's most distant explorer just stumbled upon proof that we're not alone in the universe? Voyager 1, launched in 1977 when Star Wars first hit theaters, has become something truly remarkable. The first human-made object to reach interstellar space, the region between stars where our sun's influence fades away. This car-sized spacecraft has traveled over 15 billion miles from Earth, so far that radio signals moving at light speed take 22 hours to reach it. When engineers send a command, they wait almost 2 full days for a response. The spacecraft carries instruments that seem ancient by today's standards: magnetometers, cosmic ray detectors, and plasma wave sensors designed with 1970s technology. What makes Voyager's survival incredible is that it wasn't built to last this long. Engineers expected it to function until maybe the early 2000s, yet here we are in 2025, and Voyager continues whispering back to us across the stars. Its nuclear power source, running on decaying plutonium, was supposed to have died decades ago. The spacecraft also carries the famous Golden Record, a time capsule of Earth sounds, music, and greetings meant as a message to any intelligence that might find it. Little did we know this cosmic hello might have already attracted attention much sooner than anyone expected. The first anomalous signal. In the endless stream of data flowing back from Voyager, something appeared that would change everything. A tiny flicker that seemed like nothing at first. Space is full of dust and radiation, and occasional weird readings are normal, so NASA's Jet Propulsion Laboratory initially dismissed it as background noise. Suzanne Susie Dodd, one of the mission specialists who first noticed the anomaly, described it as like shouting into a canyon for decades and finally something shouts back. The reading was faint, just a slight reflection of light picked up by Voyager's sensors that seemed too minor to investigate further. But then something changed. This wasn't just a particle floating randomly through space. The object moved in a way that caught everyone's attention. It curved, accelerated, and didn't tumble chaotically like debris would. Instead, it glided smoothly, as if under intelligent control. When Voyager's plasma sensors registered a shift that seemed deliberate and focused, the team realized this wasn't background noise. Jonathan D.A. Clark observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock, suggesting it had intention. That observation changed everything, because in the physics of space, things don't just move with purpose unless something is making them move that way. Ruling out natural explanations. When something unusual appears in space, scientists have a standard playbook. They systematically check all familiar possibilities. Is it a small moon, distant comet, or new asteroid? One by one, the team worked through these options, and one by one, each possibility fell away. This object wasn't a planet, far too small. Not a comet either. There was no tail, no ice trail, no heat signature. It didn't glow like a star, and gravitational lensing couldn't explain what they were seeing. Even space dust was ruled out because dust doesn't suddenly change direction mid-flight. Dr. Nicola Fox at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known models. What makes space objects usually predictable is physics. Everything moves according to known patterns and forces. But this object broke those rules. Its path bent in ways that didn't match any known orbital behavior, with no drift or decay expected from natural objects. The team was forced to admit something difficult. What they were seeing wasn't just unknown, it was unnatural. The movement pattern suggested intelligence, or at least design. The object seemed to be moving with purpose on a specific trajectory that couldn't be explained by gravity, solar wind, or any other forces that typically influence objects in space. It was as if something was guiding it, adjusting its course with precision. Confirmation from Voyager 2. Just as scientists were trying to make sense of what Voyager 1 had detected, something extraordinary happened that transformed this curious anomaly into something far more significant. Voyager 2, the twin spacecraft following a completely different path millions of miles away, detected something eerily similar. The same kind of magnetic fluctuation, the same kind of pulse, a matching signal signature that changed everything. This was the turning point in the investigation. Two different probes, two separate instruments picking up nearly identical phenomena ruled out the possibility of internal error. It wasn't a software glitch or sensor malfunction on Voyager 1. Whatever this was, it was real and happening in multiple directions of space. ESA analyst Mark Fontaine compared it to two lighthouses both catching a flash of something passing between them. This cross-confirmation gave the anomaly weight and credibility. It wasn't noise. It wasn't Voyager acting up. It was a real, coordinated phenomenon happening in the space between stars. The team now had evidence that couldn't be dismissed. Something was moving through the region where both Voyagers were traveling. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation used only for phenomena that don't fit within our current scientific understanding. The event was real, the math was consistent, the movement appeared deliberate, and nobody knew what to make of it. The formation of 305 objects. When the team analyzed the full telemetry logs, what they discovered sent chills down their spines. This wasn't just one or two anomalies moving through space, there were 305 objects, all moving together in formation. Each one glided past Voyager 1 in what appeared to be a choreographed arc, smooth, precise, and coordinated. These weren't debris fragments scattered randomly. There was no heat signature, no tails, no signs of decay you'd expect from natural objects. Most striking of all, the reading showed rhythmic pulses echoing through the plasma waves, the kind of pattern you'd expect from something engineered, not formed by chance. The 305 objects weren't simply passing through randomly. They were moving together as a unit, maintaining relative positions to each other in a way that suggested organization and purpose. In space, groups of objects tend to spread out over time due to slight differences in velocity and gravitational influences. Yet these objects maintained their positions relative to each other with precision that seemed impossible without some form of control or guidance. Some scientists compared it to watching a flock of birds or school of fish, except these were in the vacuum of space where such coordinated movement shouldn't be possible without technology. What made this discovery particularly unsettling was the scale. 305 objects all moving with the same unnatural characteristics, all passing by Voyager at roughly the same time suggested something far more significant was happening in interstellar space. The language of rhythmic pulses. As scientists examined the data more closely, something truly strange appeared in the signals. Patterns of repetition that weren't the kind you'd expect from stars or cosmic background radiation, but steady, measured sequences that suggested communication or control systems. The plasma wave pulses coming from these 305 objects had loops, sequences, and structures that hinted at something more complex than random cosmic noise. They didn't just pass by Voyager, they seemed to broadcast signals as if they were pinging, scanning, or talking to each other. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or a system. The idea was shocking, but increasingly difficult to ignore. These objects weren't moving in a chaotic swarm, but in an ordered, intentional formation similar to how programmed drones might operate. Some experts went further in their assessment. ESA's Eric Lousy suggested this could be some sort of probe network, though he was quickly asked to stop speculating publicly. Even typically, grounded scientists like Neil deGrasse Tyson admitted there were patterns in that data that aren't random. To be absolutely certain they weren't seeing a glitch, the team activated one of Voyager's oldest subsystems, a backup telemetry channel that hadn't been used since the 1990s. The backup system confirmed everything the primary systems had detected. The signals, the paths, the formations, all identical readings sent through a completely different channel. The implications were staggering. Impossible propulsion systems. Voyager's readings didn't just capture the presence of the objects, they revealed how these mysterious entities moved through space, and this is where things got even stranger. There were no engine flares, no ion trails, no signs of any propulsion system we would recognize, yet Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally. Some were moving faster than anything humans have ever launched. According to the data, some speeds even exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't objects drifting passively through space. They were powered somehow, moving with purpose and incredible speed. Dr. Eric J. Zernstein from Princeton noted that they're not floating through space, they're navigating it. But what worried him more was their path. These objects didn't come near Earth or show any interest in our solar system. They passed by at a calculated distance as if deliberately avoiding us or simply had no reason to stop. The method of propulsion remained a complete mystery. Nothing in our current technology even comes close to explaining how these objects move. They appeared to be manipulating space itself, creating waves or ripples in the fabric of space-time that allowed them to glide forward without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure, as if these objects were using the medium of space itself to move. Earth detects the echoes. While NASA focused on Voyager's raw data, something odd started happening back on Earth that would make this mystery even more compelling. Across various corners of the globe, amateur radio operators, some just hobbyists with backyard setups, began reporting strange activity. They were picking up weak, irregular pulses, a kind of rhythmic static that didn't match any known terrestrial source. At first, it seemed unrelated, just coincidence. After all, radio interference happens all the time. But then the reports were time-stamped and compared. They aligned almost perfectly with the same hours that Voyager had recorded its most intense plasma anomalies. These weren't professional observatories or part of any official deep space listening effort. Most of these setups were built from spare parts, tuned to catch meteor scatter, amateur satellites, or solar flare chatter. Yet somehow they were detecting faint echoes of what Voyager had picked up billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in the ionosphere. This raised a troubling question. Was this bleed-through accidental or was it purposeful? Was something out there testing Earth's listening capability, dropping breadcrumbs for us to follow? That uncertainty kicked off a quiet storm behind the scenes. NASA began encrypting parts of its deep space telemetry feeds, and intelligence agencies took notice, beginning discussions about electromagnetic security and whether these signals could be weaponized or intercepted. The machine awakens. Then, as if things weren't strange enough, Voyager itself started acting differently in ways that defied explanation. Its guidance system, called the AACS, Attitude and Articulation Control System, began misbehaving, not catastrophically like a crash. But it started routing data through old, long unused systems, almost like it was bypassing its own core software. At first, engineers thought it was a bug. After all, this is a 47-year-old spacecraft running on code older than most people analyzing it. But the deeper they looked, the weirder it got. Voyager wasn't failing. It was reconfiguring itself, reactivating memory segments that hadn't been touched in decades, rerouting its telemetry in ways that were never programmed. Then came the kicker. This behavior began right after one of the magnetic pulses from the passing objects. Could that burst have flipped a bit of memory? Could it have triggered some dormant function buried deep inside Voyager's ancient architecture? What engineers found was both promising and terrifying. The machine was stable, the instruments were fine, but the new behaviors weren't going away. Whatever was causing them, it wasn't internal decay or software corruption. Voyager had touched something, or something had touched Voyager, and the spacecraft was different now. To understand what was happening, engineers had to dig deep, literally opening dusty file cabinets at NASA's Jet Propulsion Lab. Most of Voyager's software was written in early assembly language, with some instructions existing only as notes in 1970s paper manuals. Part of something bigger. As scientists continued analyzing the strange signals pulsing through Voyager's instruments, a new and even more extraordinary idea began to take shape. Among the plasma wave readings, certain patterns stood out, pulses that didn't behave like natural energy bursts but looked structured, measured, and intentional. Then someone noticed something else. The waveforms resembled quantum oscillations used in modern quantum entanglement experiments. These are the same kinds of signals researchers use on Earth to transmit information between particles separated by distance. It was subtle but undeniable, opening the door to a possibility no one had considered before. What if Voyager wasn't just recording random events in deep space? What if it had become part of something bigger? Maybe the 305 objects weren't just flying by. Maybe they were transmitting, broadcasting data through the interstellar medium using methods we don't yet understand. By pure chance or maybe by design, Voyager was in the right place at the right time, with the right kind of analog sensors to pick it up. The signals didn't behave like random noise. They repeated, they looped, they followed harmonic intervals that looked eerily close to what you'd expect from encoded information. Something deliberately packed with meaning. Voyager, being such an old machine, might actually be the perfect listener. Modern probes are too noisy, filled with high-frequency electronics constantly transmitting and receiving chatter. But Voyager is slow, quiet, and analog. It has no clutter, no broadband digital static. It is, in a sense, the perfect ear in a cosmic concert hall, and being far outside the solar system, it's free from Earth's electromagnetic interference, just out there in the dark, listening like a perfect cosmic microphone. The mystery of Voyager's impossible encounter with 305 coordinated objects challenges everything we thought we knew about the emptiness of space. Whether these entities represent advanced technology from an unknown civilization, or natural phenomena operating by rules we haven't discovered, one thing is certain: the universe is far stranger and more populated than we ever imagined. As Voyager continues its eternal journey through the cosmos, it carries with it the possibility that humanity has just received its first glimpse of intelligence beyond Earth. What do you think these mysterious objects really are? Share your thoughts below, hit that like button, and subscribe to Future Facts for more mind-bending space discoveries. Until next time, keep looking up. A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe, set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. SWAN's dramatic arrival. What if a new object appeared in the sky tonight, so large it dwarfed everything we've seen in a generation? That's exactly what happened on September 12, 2025. Data from the Solar Wind Anisotropies, or SWAN instrument, a wide-field camera aboard the SOHO spacecraft, revealed a bright, unmistakable object blazing through the solar system. The initial readings were staggering. Its tail stretched nearly 2.5 degrees across the sky, which is about 5 times the width of a full moon. For a newly discovered comet, this scale is almost unheard of. For comparison, the famous comet Hale-Bopp's tail was about as wide at a similar distance. Initial photometry clocked it at a magnitude of 7.4, a brightness level that makes it an easy target for backyard telescopes and even powerful binoculars. The news spread like wildfire, and amateur astronomers scrambled to confirm what the satellite had seen. Just 2 days later, an observer in Australia captured a dramatic image showing a streak of light so immense it barely fit in the camera's frame. The immediate reaction wasn't just excitement, it was disbelief, as the object was already outshining professional predictions by a factor of 4. This was no ordinary icy visitor. The sheer size and luminosity didn't match any recent precedent, forcing comparisons to legendary comets of the past. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but SWAN was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are too perfect to be random. C/2025, R2 or SWAN wasn't the only newcomer drawing attention. Just days before its discovery, another object, the Interstellar 3 I/Atlas, was already on its way in, approaching from a completely different sector of the sky. SWAN's path originated from the direction of Aquarius, while Atlas emerged from Sagittarius. On a star map, their arrival vectors are separated by more than 100 degrees of the sky. And yet, both are scheduled to reach perihelion, their closest point to the Sun, within the same 10-day window in October. SWAN will arrive around October 20th at a distance of about 1 AU, the same as Earth's orbit. Atlas will skim past the Sun just 3 days earlier on October 17th, at a distance of roughly 1.36 AU. This puts their perihelion points only about 50 million kilometers apart, closer than Mars ever gets to Earth. Their orbital geometry is just as striking. Both are on steeply inclined paths, with SWAN tilted over 60 degrees and Atlas at a near-polar 85 degrees to the plane of our solar system. According to experts like Dr. Paul Chodas at NASA's Center for Near-Earth Object Studies, the odds of two such objects from such different origins, arriving in near-perfect synchrony, are vanishingly small, estimated at less than 1 in a billion. Atlas breaks the rules. So, what happens when an object just flat-out refuses to follow the laws of physics as we know them? Well, 3I/Atlas first caught astronomers' attention by, honestly, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that really set off alarms: a body dominated by nickel with virtually no iron, a ratio that's just unheard of in natural celestial objects. This, totally contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends, similar to chondritic meteorites. The claim was so radical that some labs immediately called for data re-verification. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. What really couldn't be explained, though, was its motion. Observers noted 3 distinct non-gravitational accelerations, each providing a delta V of several meters per second. Now, these weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object that showed similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and, honestly, much more powerful. SWAN, the fortress. One object acts like a drone, the other like a battleship. C/2025 R2 or SWAN is really in a league of its own. Its sheer scale is breathtaking, but honestly it's the finer details that have experts truly puzzled. The first whispers of something strange began with reflectance data showing an unusually high albedo of 0.6, similar to fresh snow, whereas typical comet nuclei are darker than asphalt, with albedos below 0.05. Some amateur spectroscopists even argue the data matches a nickel-cobalt alloy, which is a material used on Earth for its immense strength and resistance to corrosion. This led to the term nickel-cobalt hull circulating in online forums. Then came reports of an optical anomaly, a persistent silvery halo around the nucleus that seemed to shimmer. Some experts theorize this could be a plasma envelope or a mini magnetosphere, acting as an electromagnetic shield. And that's where the nickname the Fortress comes from. Unlike the agile Atlas, SWAN moves like a tank, slow, steady, and, honestly, seemingly invulnerable. Its record-breaking tail also shows evidence of microthrusts, tiny, rhythmic pulses that suggest precision course corrections, far too regular to be random outgassing from surface fissures. Mission theories. Coincidence, or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really just plummet. This has fueled a whole wave of mission theories. The first, and probably the most routine, is a scheduled refueling run, with the Sun acting as a kind of cosmic pit stop for two engineered probes. A second, less peaceful theory suggests an intervention or maybe even a confrontation, especially given the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I/2017 U1, was the first scout, followed by 2I/Borisov, and now Atlas and SWAN represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the Sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or energy top-up is standard practice for our own probes, like the Parker Solar Probe, making this theory honestly chillingly plausible. Ancient connections. Could our history be written in the stars, just waiting for the right moment to be read? SWAN's enormous 22,554-year orbit is a direct link to the last ice age. Its last visit to the inner solar system would have occurred around 20,000 BCE, a time of immense climate change when human civilization was really in its infancy. This same epoch left its mark in the ice cores of Greenland and Antarctica, where layers of dust hint at, dramatic celestial events. At the heart of this idea is Göbekli Tepe, a mysterious site in Turkey built around 9600 BCE. Its stone pillars are carved with symbols, some of which are interpreted by researchers like Martin Sweatman as depictions of comets. His controversial analysis of Pillar 43, the Vulture Stone, suggests it records a catastrophic comet impact that triggered a mini ice age. Mainstream archaeologists and astronomers strongly caution that these connections are, speculative. Still, the timing is hard to ignore. SWAN's last passage happened just as human culture was taking its first steps toward tracking the heavens and building monuments, leaving open the tantalizing possibility of a forgotten history. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both SWAN and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is, incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers, speaking off the record, have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When official channels go dark, the people light the way. The observation blackout may have silenced government agencies, but it sparked a fire in the global community of independent astronomers. Bill Gray, a veteran tracker renowned for his open-source orbit calculations, rallied a distributed network of backyard observers and small observatories. His call to action spread across forums with a clear message: keep your scopes on the sky, log every flicker, and share the raw data. In Europe, amateur collectives began pooling wide-field sensor feeds, while leaks from private groups suggested makeshift plans to bypass the blackout using radio telescopes, like the Allen Telescope Array, hoping to detect emissions from the objects themselves. With big institutions locked down, this grassroots effort, relying on publicly available data from surveys like the Zwicky Transient Facility, has become the only real-time source of information. It's really a testament to the power of citizen science. If we're going to get answers, they might just come from someone's backyard, not a government lab. Power estimates and implications. Let's talk about the energy, because the numbers are honestly staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants, like the Palo Verde generating station. But SWAN makes that number look, insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, The most extreme estimates place its power output at a mind-boggling 10,000 gigawatts, or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1, or even Type 2 civilization. These figures push the conversation beyond academic debate, and into a realm that forces us to question everything we thought we knew about our place in the universe. Here's the bottom line. Two of the most anomalous objects ever detected have entered our solar system on a synchronized path. Their composition and behavior defy our current understanding of comets, and their arrival coincides with an official observation blackout that has silenced the world's most powerful telescopes. We are left with a grassroots network of citizen scientists working to uncover the truth and energy readings that point not to nature, but to technology. Whether this is a cosmic coincidence, a peaceful rendezvous, or something else entirely, we may soon find out when they emerge from the sun's glare. The only question left is, what will we see when they come out the other side? Don't forget to like, subscribe, and hit the bell icon for more updates on this developing story. Thank you for watching Future Facts.